Hello everyone and welcome to the chapter number 41 of Blender Master Course Geometry Nodes Creating a Riverboat Scene. In this chapter we'll be learning about all these topics in complete detail and we'll be using them to create this simple scene with the landscape, the flowing rivers and some boats. And yes, if you are new to this course then do check out the previous 41 chapters from the link of the playlist in the pinned comment. So to begin with, let's open the Geometry Nodes workspace. Now go to the Geometry Nodes editor and click on the new button. To get a plane instead of this cube, we'll be using the grid node. So press Shift plus A, go to mesh and in primitives select the grid node. Let's place it over here. Now to scale it up, I'll go to the size option in the X and Y axis and let's increase it to something like 50. Let's also increase the number of vertices in both X and Y axis to something around 10 or 12. And now the first node that we are going to understand today is the edge paths to curve node. To add it here, press Shift plus A, go to mesh and in operations, here we have the edge paths to curve node. So let's select it and place it over here. Now what this node does is that it basically takes a mesh as an input and gives an output in the form of a curve, and to be more specific, it takes the edges of your mesh based on the start vertices and the next vertex index, and then it converts the path of those edges into curves. To understand it better, I'll take this node and drop it over here, and we observe that everything disappears, and that's because we have not yet connected anything to the start vertices and the next vertex index. In the start vertices socket, we basically have to connect information about that particular index from where the path should start, and suppose you want that the path should begin from the vertex having a particular index value. So for this we have to use the index node and the compare node. So press Shift plus A, go to geometry and in read select the index node. Let's place it over here, and now to add the compare node, press Shift plus A, go to utilities and in math select the compare node. Let's place it over here, and now since we'll be connecting the compare node to the index, so I'll change the input type from float to integer and the operation to equal. Now I'll connect the index socket to the value A and the result socket to the start vertices. Now this compare node is basically acting as an input to tell the edge paths to curve node that the starting vertex will be that particular vertex whose index value is equal to the value of B, which is 0. And now the next socket that you have here is the next vertex index, and basically here we have to tell this socket that how should it connect the next vertices after the starting vertex, and to use it we have to connect it to another node which is the shortest edge path node. To add it here, press Shift plus A, go to mesh and in read, here you will find the shortest edge paths node. So let's select it and place it over here. Now the shortest edge paths node will basically create the shortest path between the starting vertex and the ending vertex that will connect to the end vertex socket. So if I take the next vertex index and connect it over here, and for the end vertex I'll select the index and the compare node, press Shift plus D to create a duplicate and place them over here. Now I'll connect the result socket to the end vertex and let's change the value of B from here, and you will notice that as the value of B changes, this path in the 3D viewport is also changing. So to revise everything, we use the edge paths to curve node to create this path between any two vertices. Then we use the start vertices socket and connected it to the compare and the index node in order to select which particular vertex we want as the starting vertex. Then we use the short edge paths node in order to create the shortest path in between the two vertices. And for the ending vertex, we again use the index node and the compare node and connected it to the end vertex. And you can also change the length of the path or this curve by changing the ending vertex from here. Now to view the original plane along with this path, we'll be adding the join geometry node. So press Shift plus A, go to geometry and select the join geometry. Let's place it over here and connect the mesh socket of the grid to the join geometry node. Now to view the path or basically the curve, we'll be connecting it to the curve to mesh node. So press Shift plus A, go to curve and in operations select the curve to mesh node and drop it after the edge paths to curve node. To view it in the scene, we have to connect something to the profile curve node, and to extrude the path to look like a cylinder, we need to connect the profile curve socket to the curve circle node. So press Shift plus A, go to curve and in primitives select the curve circle node, place it over here and connect it to the profile curve. Let's increase the radius from here, and now you can see here that the path between the two vertices is now converted into a mesh due to the curve to mesh node and is looking cylindrical because of the curve circle node. Now one thing to notice here is that this path or basically the cylinder is straight right now, but if I turn on the wireframe from here, then you can see that in this plane we have many vertices. So if I go to the end vertex and in the compare node, if I increase the value of B, then you will notice that in order to form a path between the 2 points or basically the two vertices, it turns like this and is no more straight. So basically it is forming the shortest path in between the vertex having the index value of 0 and the end vertex having the index value of 36. Now let's also reduce the size of the cylinder from here. So we'll be keeping it to something like 1.2 or 1.3, and now let's also turn off the wireframe display from here, and moving ahead, let's convert this plane into mountains, and for this we'll be displacing the vertices in the Z axis with the help of noise texture. So go to the geometry nodes editor and first add the set position node. So press Shift plus A, go to geometry and in right select the set position node. Since we'll be working on the plane, so we'll drop it in between the grid node and the join geometry node. Now for the noise noise texture, press Shift plus A, go to texture, and here we have the noise texture. We'll place it over here and connect the factor socket to the offset. Now the reason why we can't see much effect here is that in the grid node, the number of vertices is very low. So I'll select both of them and let's increase it to something like 100, and now the noise texture is applied. To make it look like mountain, I'll first reduce the scale value of the noise texture to a much lower number like 0.1 or 0.2, and to magnify this effect of the noise texture, we'll be using the math node with the multiply operation. So press Shift plus A, go to utilities, and in math, select the math node, drop it over here and change the function to multiply. And if I increase the value from here, the effect of the noise texture will multiply in all the three axes. But since we are making the mountains or basically the hills, so we need this to be applied only in the Z axis, and so we'll be using the combine XYZ node. So press Shift plus A, go to utilities, and in vector, select the combine XYZ node and drop it after the multiply node. It looks like this because by default it is connected to the X axis, but if I break this node connection by holding Control, right clicking and dragging like this and connect it to the Z axis, and now we have these mountain like structures. And now to define the shape of the mountains, we'll be using the RGB curves node. So press Shift plus A, go to utilities, and in color, select the RGB curves. We'll drop it after the noise texture node, and now it's connected over here. Now we have not yet studied about the RGB curve in the geometry nodes, and we'll be completely understanding it in one of the upcoming chapters of the course, but for now we'll be using it to define the shape of the mountains. So in the RGB curves node, if I left click on any part of the curve, a new handle will get created here, and from here we can change the type of this handle. So if I select the second one, which is the vector handle, and try to change the position of this handle, then you will notice that the way this texture was looking on the plane will also change. Similarly, if I select this handle over here and bring it down like this, then this is how the texture looks now. Similarly, if I bring the second handle close to the third one, then the effect of the texture will increase. So you can try to change the position of these handles and get different results each and every time. However, to make them look like mountains, we basically have to invert this effect of the texture. And for this, I'll go to the multiply node here and take this value to a negative number. So I'll keep it to something like -35 or -40, and this is how it looks. Now the plane has also moved down because we added a negative value here, and to fix this, we'll use the vector math node. So press Shift plus A, go to utilities, and in vector, select the vector math and place it before the offset socket. And now to move it upwards, I'll increase the vector value in the Z axis like this. Let's keep it to something like 20, and now the plane has moved up in the Z axis. Now one thing to notice in the geometry nodes editor is that the edge paths to curve node that we added here is connected to this grid socket. As a result, it will only consider the original plane which was not having the mountains. So to make sure that the path also considers the mountains that we created, we'll be connecting the geometry socket of the set position node, which is carrying all the information about the texture, to the mesh socket in the edge paths to curve node. So I'll take this geometry socket and connect it to the mesh, and now this path is also considering the mountains on the plane. To increase the length of this path, I'll go to the end vertex, and in the compare node connected to it, I'll increase the value of B from here. So let's keep it to something like 4000 or 6000, and this is how it looks now. We'll be using this path in order to make the river flowing through the landscape. And one more thing, let's also reduce the radius to something like 0.5, and now suppose we want that this path, or basically the river, doesn't flow over the mountains but instead change its path on the landscape whenever there is a mountain ahead. And for this we'll be using the edge vertices node. To add it here, press Shift plus A, go to mesh, and in read, select the edge vertices node. Let's place it over here, and in this node we are having 4 sockets. The first 2 are the vertex index and the last 2 are the position sockets. So it basically gives the information as output about the vertices that form an edge. So as we all know that an edge is formed by 2 vertices connected to each other. So from the vertex index 1 socket, it will basically give the output of the index of the first vertex. Similarly, the vertex index 2 will give the output of the index value of the second vertex forming the edge. Then you have the position sockets, which will tell you about the position of the 2 vertices through the position 1 and the position 2 node respectively. Now let's also understand how we are going to use the edge vertices node in order to place this path or the river only on the base of the landscape and not on the mountains. So if I turn on the wireframe display from here and zoom in, then you can clearly see that the edges at the base of the landscape are having a different length as compared to the edges of the mountains. If I take the annotate tool from here and select the annotate line, then here on the base of the landscape, a single edge is around this much long, and this length is constant throughout the base. However, the length of the edge in case of these mountains is much larger than compared to the base of the landscape. Moreover, unlike the edges of the base, these edges of the mountains are having different lengths. distance. Some of them are smaller and the others are longer. So with the edge vertices node, we'll be measuring the distance between the position 1 and the position 2, that is the position between each of the two vertices forming an edge, and we'll be connecting it to the shortest edge path node so that the path is placed only on the base of the landscape and not on the mountains. But before that, I'll select the annotate eraser tool from here and let's remove these annotations. Let's also go to the select tool again and turn off the wireframe display from here. Now we need to measure the distance between the position of the first vertex and the second vertex, and for this we'll be using the vector math node. So press shift plus A, go to utilities, and in vector select the vector math. Let's place it over here, and in the list of operations, one of the operations that we have here is the distance operation. So I'll select it, and if I connect the position 1 to the first vector socket and this one to the second vector socket, then now this vector math node with the distance operation will basically measure the distance between the position of the two vertices for each and every edge. And if we connect it to the edge cost socket in the shortest edge paths node, then the edge cost will only accept those vertices which have the minimum distance in between them. So if I take the value socket and connect it to the edge cost, then in this case the path, or basically the river, is present only on the base of the landscape and not on the mountain. Now let's revise this concept again. We use the edge vertices node in order to calculate the position of the two vertices of each and every edge. Then to calculate the difference between the two positions, we use the vector math node with the distance operation, and then we connected it to the edge cost socket, which only considers the minimum value as the input. And since we already discussed that the length of the edges of the base of the landscape are smaller than those of the mountains, as a result the shortest edge paths node will try to find the shortest path between the two vertices that we selected using the compare and the index node, and connected all of it to the edge paths to curve node in order to form this path. And now moving ahead, if I zoom in, then you can see here that this path is having a lot of turns, and since we'll be using it to create a river, so obviously we won't need so many turns in the river. So to fix this problem, we have to use the resample curve node. So press shift plus A, go to curve, and in operations select the resample curve and drop it in between the edge paths to curve node and the curve to mesh node. Now we can change the number of turns with the count value here. So let's keep it to something like 14, and this is how it looks. Now since we are making this path for the river, so let's also create a carving, or basically some space for the river to flow. So for this, we'll go to the set position node here, which is carrying all the information about the base of the landscape, such as the noise texture and the multiply effect applied to it. And then to create the carving, we'll basically displace the vertices according to this path. And for this, we'll be using another set position node. So I'll select this one, press shift plus D to create a duplicate, and place it after the first set position node. And now we want that the displacement should be according to this curve or the path where the river will flow. And for this, we'll be using the geometry proximity node. We learned about it in the chapter number 38 of the course, where we created a meteor apocalypse scene. And to add it over here, press shift plus A, go to geometry, and in sample select the geometry proximity node. Now this node is basically used to displace the position of vertices of any particular object based on some other geometry which we add as the input in the geometry socket. So I'll take the mesh socket of the curve to mesh, which is carrying the information about this path, and connect it to the geometry socket here. And to see the effect, I'll connect the distance socket to the offset in the set position node. Now it looks like this because the effect of displacement is being applied in all the three axes, and to control this effect only in the Z axis, I'll be adding a vector math node here. So press shift plus A, go to utilities, and in vector select the vector math and place it after the geometry proximity node. To control the effect of the displacement, I'll change the operation from add to multiply, and now I'll increase this vector value in the Z axis. So if I increase it to something like +1, then here you can see that the effect of the displacement on this entire plane because of this path or the curve is too high. And to control this, we'll use the map range node. So press shift plus A, go to utilities, and in math select the map range node. We'll drop it before the multiply node here, and now we have the desired result. If I zoom in, you can see the carving for the river along this path, and you can even control its size by the from min parameter in the map range node. So if I slightly increase it, you will notice that the size and the appearance of the carving around the path is also changing. So I'll keep it to a value of something like 0.4, and this is how it looks. Now for the water of the river, we'll basically be adding a plane in the geometry nodes editor and connect it to the join geometry node. So press shift plus A, go to mesh, and in primitives select the grid. Let's place it over here, and we'll connect it to the join geometry node. Now a small plane is added at the same position as that of the original plane, and if I increase its size in the x and y axis like this, then at a particular value you will begin to notice that the plane is now visible on the carving that we created. So we'll scale it up to something like 50, and if you want to move this plane upwards or downwards, then for this you can use the transform node. To add it here, press shift plus A, go to geometry, and in operations select the transform geometry node and drop it after the grid node. Now with the help of the translation in the Z axis, we can control the position of the plane, or basically the water of the river, as per the carving been created due to the path. And now moving ahead, let's give some life to our scene by adding some material to it. So since we are making a scene of a mountain, so we'll be downloading some PBR textures for the cliffs or the mountains. So for this purpose, I have opened this website of polyheaven.com and I'll go to the browse textures. Then in the search bar, I'll type cliff, and here we'll get all the cliff or the mountain textures, and we can select any of these for the base of our landscape. So I think that we should go for this one, which is Coast Sandrocks 02. So I'll select this and click on the download button here. Now the zip folder will get downloaded, and do ensure to extract it in the file explorer before using it in Blender. Now we are back in the scene, and to apply the downloaded material, first we'll change this window to the shader editor. So click on this icon and select the shader editor. Now here we have the default principal BSDF applied, and to add the downloaded PBR material, first we'll select this principal BSDF by left clicking on it and then press Ctrl plus Shift plus T, and now this window will open from where you have to find that particular folder that we downloaded and extracted. So I'll open this folder, then open the texture folder, and here we have these 4 files. I'll select all of them and click on this principal texture setup. Now to apply this material to this base, we'll go to the geometry nodes editor from here, and we'll be adding the set material node. So press Shift plus A, go to material and select the set material node, and we'll place it after the set position node, which is having this information about the noise texture which we use to displace the vertices of this plane. And you can see here that all these nodes starting from the noise texture to this multiply node are connected to the set position node here. So I'll go to the set material, and from here we'll select this material. Now to view the material, let's go to the render view from here. Now to get some lighting in the scene, click here and we'll turn off the scene world. Now the reason why you can't see the texture properly is that if I go to the shader editor from here, then you can see in the texture coordinate that we have connected the UV socket to the vector. And to get the material properly applied here, I'll take the generated socket and connect it to the vector. And now we have this PBR material perfectly applied to the base. Now moving ahead, let's also create some material for the river that we created here. So for this, let's again go to the geometry nodes editor from here, and we'll be creating a duplicate of the set material node and connect it to this curve to mesh node which we use for creating the path. So I'll select the set material node from here, press Shift plus D, and I'll drop it here. Let's go to the material properties, and to create a new material, click on the plus button, then click on the new button, and to add this material in this set material node, click here and select the material.001. Now let's go to the shader editor to modify this material. Now let's zoom out, and here we have the default material applied for the material.001. And to make it look like water, I'll first change the base color from here. So let's keep it to dark blue color. Right now you can see that this blue material is only getting assigned to the paths that we created and not the entire river. So to fix this problem, I'll go back to the geometry nodes editor, and we'll be connecting the set material node to this grid and the transform geometry node, which are carrying the information about the plane that we added below it in order to make the river. So with this set material node selected, press Shift plus D and place it after the transform geometry node, and now we have this blue material applied to the entire river. To make it look like realistic water, I'll go back to the shader editor again, and now we'll be using the noise texture. So press Shift plus A, go to texture and select the noise texture. Let's place it over here, and we'll be connecting it to the bump node in order to give the water a 3D look. So press Shift plus A, go to vector and select the bump node. Let's place it over here. Take this factor socket and connect it to the height, and take this normal socket and connect it to the normal in the principal BSDF. To see the difference here, I will increase the scaling in the noise texture to something like 50 or even higher, and now this is how the texture of the river is looking right now. Now finally we will be modeling some boats to place on this river. So for this, press Shift plus A in the 3D viewport, go to mesh and select the cube. To focus only on the cube, press the forward slash button. Now to change this into a boat, tab into the edit mode. I'll first scale it up in the Y axis. So press S and Y and scale it up like this. Let's also scale it up slightly in the X axis. So press S and X and scale it up like this. Now press 3 for the face select mode, and now we'll be selecting this bottommost face and we'll extrude it to make it look like a boat. So press E to extrude it, and let's extrude it in the Z axis like this. Press S to scale it down, and this is how it looks now. We'll be keeping the model very simple and basic, but let's also create an inset on the top face and we'll extrude it downwards also. So with this face selected, press I to apply the inset, then left click to finalize, press E and extrude it downwards like this, then left click to finalize, and now this is how the structure of our boat is looking right now. Now if you want, you can even extrude these smaller faces at the side and scale them down. So to do this, I'll select this face, press E to extrude it like this, and let's scale it down and left click to finalize. I think that we have extruded it too much, so press G and Y and let's bring it back in the Y axis. Similarly, I will select this face, press E to extrude it like this, and S to scale it down. And with this, the basic structure of our boat is now ready. If you want to make it look even more complex, then for this you can add a cylinder with a flag over it. So for this, I'll press Shift plus A again, go to mesh and add the cylinder, tab into the edit mode. To reduce its thickness, press S and Shift plus Z and scale it down down like this. Now to increase its height, press S, Z and scale it up like this. Let's also move it slightly upwards in the Z axis. So press G and Z and move it over here. Now to add a simple flag at the top, we'll use the plane object. So let's come out of the edit mode, press Shift plus A, go to mesh and select the plane, move it upwards in the Z axis and place it over here. Let's tab into the edit mode, and to rotate it properly, press R, Y and type 90 to get a rotation like this. Let's also scale it up in the Y axis like this, and now we have a simple boat ready for the scene. So let's come out of the edit mode. To join all these separate parts together, I'll select all of them, press Ctrl plus J to join all these objects. Now to remove the focus from this boat and get back the entire scene, we'll press the forward slash button again, and this is how this boat is placed in the scene. To place it properly on the river, press 7 to go to the top view. Let's zoom out, press G and place it over here. Let's tab into the edit mode, press A to select everything and scale it down like this. Let's also rotate it in the Z axis, so press R, Z and rotate it like this. Now let's come out of the edit mode, press 0 on the numpad to go to the camera view. Let's enable the lock camera to view from here, and this is how this river scene with the boat is looking right now. Let's do one more thing, which is to move this boat slightly downwards in the Z axis. So we'll place it over here and left click to finalize. And now let's give this boat some simple materials. So for this, let's go to the material properties, click on the new button. Let's change the base color to the brown color by reducing the brightness from here, and you can see that this brown color is applied to the boat as well as the flag. To assign some separate color or material to the flag, simply go to the edit mode, deselect everything, and I'll select this face, go to the material properties, click on the plus button, create a new material, and to assign this material, click on the assign button. Let's change the base color to red color and come out of the edit mode. With this, we have the boat ready in the scene with this simple river and these mountains created with the help of geometry nodes. And with this, our scene is now completely ready. However, before ending this chapter, we'll be understanding one more geometry node which is not related to this scene, but it is still very important, and it is the edge neighbors node. So to understand this node, we'll be adding a plane in the scene. So press Shift plus A, go to mesh and select the plane, press G and Y and place it over here. Now tab into the edit mode, press S to scale it up like this, and let's move it over here. Now to increase the number of vertices, right click and select subdivide, and we'll increase the number of cuts from here to something like 3 or 4. Now what I'll do is that I'll turn on the edge select mode by pressing 2, then I'll select some random edges from here, create a duplicate of them by pressing Shift plus D and move it in the Y direction over here. Now let's come out of the edit mode, and here we have this plane with these duplicate edges placed over here. Now if we go to the geometry nodes editor from here and click on the new button, then we have this default setup of the geometry nodes. Now to change the position of this plane, I will add the set position node. So press Shift plus A, go to geometry, and in right, select the set position node. Let's place it over here, and if I go to the offset value and try to change it in any of the 3 axes, you will notice that the change in the position is being observed on both the plane as well as the edges. Now let's also add the edge neighbors node and understand it. So press Shift plus A, go to mesh, and in read, select the edge neighbors node. Let's place it over here, and you can see that in this node we have this face count socket. So basically what it does is that it will count the faces that are adjacent to an edge. To understand this better, I'll go to the edit mode of this plane, and you can see here that if I select this particular vertex, then the number of faces adjacent to it is 2. The first one is this face and the second one is this face. However, if I select this edge at the corner, then this one is having only one adjacent or the neighboring face. So the face count for this edge will be 1 and the face count for this edge will be 2. In the same way, if I select any of these edges, then you can clearly see that there is no face adjacent to these edges. As a result, their face count will be equal to 0. So we can use the edge neighbors node in order to tell the set position node that we want the changes to be applied only on some particular edges having a specific number of face count. So if I come out of the edit mode and in the geometry nodes editor, if we add the compare node by pressing Shift plus A, going to the utilities, and in math select the compare node, and if I drop it over here, then now I can use it to create a connection between the edge neighbors node and the set position node. So first of all, since the number of faces is an integer, so I'll change the input type from float to integer, then I'll change the operation to equal, and now I'll connect the face count to the value A and connect the result to the selection socket in the set position node. Now what it will basically do is that it will check that which particular edge has a face count equal to the value of B, which is 0, and then whatever changes I do in the set position node will be applied to only those set of edges. Right now, since the value of B is 0, and as we already discussed that the duplicate edges that we created here are having a face count of 0, so if I go to the offset and try to change it, then you will notice that only the position of these edges is changing, which are having a face count equal to 0. Similarly, if I increase the value of B to 1, then in this case the offset is being applied to all those edges who are having a face count equal to 1, and since we already observed that all the corner edges were having only one adjacent face, as a result they were having a face count equal to 1. Now if I increase the value of B from 1 to 2, then in this case the edges except the one at the corner and the duplicates are now being affected due to the change in offset values, and this is how the edge neighbors node work. It will simply count the number of faces which which are adjacent to any particular edge, and then will allow you to make the changes accordingly. And now I'll delete this by pressing X, press 0 on the numpad to go to the camera view, and this brings us to the end of this chapter. In this chapter, we learned about a lot of different nodes and used them to create this hilly area along with this river. Then we even created this simple boat and placed it here. And so our next chapter will be the chapter number 42, Geometry Nodes, part 1 of creating the candy world. So don't forget to subscribe to our channel, press that notification bell so that you can get timely updates about the upcoming chapters. Thank you for watching and we'll see you in the next one.